science and machine learning can deliver business impacts. We'll start with learning about what is machine learning and then how you connect machine learning to drive business outcomes. Hopefully you will leave today with an understanding of machine learning and where all you could apply that in your own organizations. We'll follow that up with a quick case study and move on to Q&A if we have some time. A quick overview about CoStrategix. We've been around 2006. We primarily help mid-market and smaller organizations go digital. Basically craft digital strategies, and also data strategy is an integral part of that. So we craft those and help companies navigate and bring these initiatives to life. We have a couple of locations headquartered here in Cincinnati and also an engineering center on the India side in Bangalore. We work with quite a few Fortune 500 customers as well, but our primary focus is mid-market and smaller businesses. We do quite a bit of work in data science, digital commerce, app modernization, and some of these things happen on the cloud. And also we build quite a few mobile solutions for our customers. A quick round of introductions. I'll let Jeremy introduce himself.
My name is Jeremy Henry, and I am VP of Engineering here at CoStrategix. My primary role is as a solution architect. I have around 26 years of experience in the software development and engineering realm. I have a bachelor's and a master's from MIT in Boston and an MBA from Xavier.
And this is myself. I just go by Nan, and as you can see, I have a much complex first name. Nan is my user-friendly name. 27 years or so of enterprise architecture, software development experience, an MBA, computer science from Bangalore University, India. So going to the next slide here, let's get a common understanding of what is machine learning. As you can see from a definition standpoint, right, machine learning, as per at least Wikipedia goes, is a scientific study of algorithms and statistical models that computer systems use to effectively perform a specific task without using explicit instructions, merely relying on patterns and inference instead. So let's talk about what that really means in the next couple of slides. So to really kind of understand what is machine learning, we have to understand the basis or the foundation of this particular discipline of software programming. Statistics, as you know, is a discipline concerned with collection of data, analysis, description, visualization, and generating inferences from data. On top of that is data mining. If you can automate statistical analysis on large data sets, we call that data mining. So from statistics, data mining evolved. And on top of that, expert systems emerged back 20 years ago. This was quite helpful. It was just a complex set of if-then rules. It also had a degree of fuzziness that you could build based on some probabilistic type models. But it had a very limited application. In that, the expertise was limited to the person who actually was programming that. One person had to know everything in order to program that. So essentially, you took an expert and turned out to create a software that mimicked. Machine learning takes a very slightly different approach. It enables certain, as you say, computers to learn without explicitly being programmed. But there are really software models that can take data and understand the patterns in it and kind of mimic the behaviors inherent in that pattern and act, accordingly based on that.
So one example of this would be, if you look here, there's two examples of modern art. On the left, there's a Pollock. On the right, there's a Mondrian. Now, an expert in this field would easily identify them. And most folks, if you look at them, you could, most humans can discern the difference between the two styles. But if you were a computer programmer, a developer, how would you actually write code that would be able to distinguish between these two things? What kind of, if then else logic would result in the ability to discern between these two modern art styles? So the nice thing about having machine learning as an approach is that you don't have to do that development. That's where the machine learning models come in. All you have to do is have a lot of examples of a Pollock and a Mondrian, and then you feed them in as training data into a machine learning model, and the model itself learns to make those distinctions. And how it does that, we don't really have to know. It's finding patterns, it's inferring patterns, but in the end, what you end up with is a model that can make that distinction. So what does that look like in practice? Is what you have is the training data feeds into a model factory, and it's the model factory that produces the model that would actually be used in your business processes. Now, in practice, that model is usually encapsulated within an API, and most businesses today are familiar with APIs. It's the ability to call business logic from a program, from a web page, from an application. So the taking of that model and incorporating it into your business processes still does require some computer programming, some development. So using ML doesn't completely remove the need for developers. It just makes the really difficult part of the development process, that pattern recognition, very simple. And then the only development that's left is incorporating that logic, that API, into your business processes. Now, the piece on the left can be done by a data scientist. The piece on the right, productizing that model, would be done by your IT or your development team.
So there are various machine learning approaches. Starting from the top, supervised learning is where you have training data available. For example, you have a financial analyst approving credit card applications. He or she is using a number of attributes to decide whether to approve the credit card application or not. So that type of decision, right, captured in data form could form the basis of training data. So by teaching that, you're essentially creating software to mimic that financial analyst. That is called supervised learning.
Unsupervised learning, it allows the ML model itself to discern patterns without having to have that data be labeled. So you don't have to label it as approved or rejected. You would just feed in the data as training data, and the machine can figure out patterns such as clustering. So it can say these pieces of data all have similar characteristics different than these other elements of data.
And reinforced learning is best observed in vacuum cleaners that are robotic vacuum cleaners that you might have at home. When they're shipped in, they do not have any type of instructions to tell what the dimensions of your living room would be. So basically it starts working and starts bumping against walls and objects and starts to learn, going this particular route, it can, in a most optimized fashion, cover the entire surface and clean it up. So that type of learning is called reinforced learning.
Deep learning is an area of a lot of interest right now because it's able to harness the value provided by all the other different types of models. So imagine a number of different machine learning stacked together so that, for example, if you're trying to identify a tiger, right, you're trying to teach an algorithm to identify tigers. What you can do is have one model that just identifies fur, and another one that identifies stripes, and another one that identifies cats, and one that identifies whiskers. And at the bottom, all that data can come together in a simple model that says if it's got fur and stripes and it's a cat and it's got whiskers, then we can identify that that's a tiger. So it's able to harness the value of the other machine learning models. And again, that's why it's getting a lot of interest in the area, in the field right now.
So going to the next slide, there are various types of software models that go within a machine learning application.
And one of the key things you'll see in ML models is that ideally, you would want the ML model to be able to answer a question. And each of these different types of ML models that we've shown here can answer a different type of question. So the first one gets into things like classification between known discrete categories. So if you want to create a model that can distinguish between a dog and a wolf, you're basically introducing a classification problem. The question you're asking, is this a picture of a dog or is this a picture of a wolf? The next one is the regression. So this is where anytime you're trying to ask a numerical question, what should be the price of this house? You would use a regression type model. And these models already exist. You can pull them off the shelf and use them. They've already been written. And there's tools that you can use to access, oh, for this case, I want a classification. For this case, I want a regression or a clustering anomaly detection. Clustering is like the one we just talked about, where you're able to, the machine learning model is able to discern characteristics that would group different data elements into categories. And anomaly detection is where it identifies this is what most normal transactions look like, and it can identify outliers. The example there would be, is this financial transaction potential fraud? So being able to identify that this one doesn't fit the pattern of all the other financial transactions that have occurred before it, therefore it's an outlier and may represent fraud.
So going to the next slide, right? So what makes machine learning very relevant today and relevant and practical today, right? Even for mid-market organizations. There are quite a few factors. The algorithms always existed in the 60s, 70s, 80s, but the amount of computing power that was needed to use them in a practical form was somewhat limited. With the clouds, hitting maturity and the cost of computing going low, that has become a significant, opens up a significant opportunity to implement machine learning models. And also these algorithms and the frameworks that are required to put this into a production type environment, all those pieces of software are now open sourced. It was once the intellectual property of top 10 companies. Maybe today, all of those are open sourced and quite easily available for any of us to write solutions.
A couple of caveats. Not every problem is a good fit for machine learning. Machine learning is primarily focused on problems where you can ask a simple question and it's based on pattern recognition, and where you have a lot of data to establish that pattern within the model. ML does still require some development effort, especially like I talked about in the productization aspect. Feature identification and extraction, when we say feature, we're just referring to the characteristics that go into the model as training data. So if it was something to learn about whether or not a particular financial application or loan application should be accepted, it may be the credit score and the age. Some of those are features that need to go in as training data. And last is overfitting and bias. And overfitting is an example where it doesn't just learn to identify cats, it learns to identify your cat. And those models become less useful the more overfitting becomes a problem.
So going to the next section here, machine learning to drive business outcomes. Let's kind of understand 5 different business impact areas within our organization. Starting with operations, production, engineering, whatever you might call it, there is a part of the business that's producing the product or service that you sell to your customer. And inside that, you're focused on the asset utilization, cost savings, capital decisions, and so on. And then the aspect of customers comes with sales and marketing. And there you're looking at the proximity to the customer, 360-degree understanding, and creating these touch points, digital touch points for these customers. And products and services themselves, how do you infuse intelligence into these things to kind of differentiate? And regulatory or risk compliance, right? You might be subject to financial regulations from a industry standpoint or insurance and so on. So there may be areas that you may have to focus there as well. Finally, transformational. This is the most exciting part. you might be able to offer a new product or service that you could not before without machine learning. And so there's a good example that we'll talk towards the end of this presentation. So if you take these 5 business impact areas, how can we go to each of these areas and see where machine learning might fit? What are the value you could observe in each of these areas, and then what are a couple of examples? Maybe we'll talk about one example in each of these areas and go through those quickly. So we'll start with the operations first. So starting with operations, we'll pick, there are a number of different areas where you could be adding value through the application of machine learning. Let's focus on one of those, which is being able to forecast accurately. Up until now, you have reports that you might be able to draw from your data warehouse or from your systems and look at what happened. And these reports often give you a rear view mirror perspective of what happened. They may not necessarily be able to predict what's going to happen. That's where machine learning may come in and change the game. And a good example of that is asset utilization, right? So if you have a fleet of vehicles and you're collecting data from these vehicles, the engine and so on, and you're observing certain rate of oil change or certain issues or maintenance on these vehicles, you will be able to feed that to an algorithm and basically predict at what point the next oil change or some kind of a fix will be required. So you can actually be proactive about it and then take care of that problem before it happens, and increasing utilization of that asset and maybe improving the asset life value as well going forward.
And there's devices now that are available and are particularly useful for fleet applications where they can provide down to the sub-second monitoring of a number of different characteristics on the engine, the vehicle, the stresses, the acceleration. What would you do with all that data? That's the perfect example of training data that can be fed into a machine learning model that can accomplish the types of thing that Nan's talking about. Calculate that mean time to failure so you can proactively get that vehicle in for maintenance so you don't lose business value with that vehicle and its technicians sitting on the side of the road.
So going to a customer impact area, if you're looking at the value that you can obtain from this particular area, knowing the customer, let's focus on that. And there's stellar examples of this. Amazon does a pretty good job, and all of us may have had that experience of finding the right product or searching for something on the periphery and ending up with the precise product that you were looking for. This is where Amazon knows what people are looking for. For example, if Jeremy is looking for a certain product and ended up with a different product that he purchased, that same learning Amazon will apply across its customer base in a calculated manner, not quite blindly, but when my profile fits this, and if I'm searching for it, it might increase the weightage to show that secondary product as probably a better fit, so that type of thing.
Another great example of this is sentiment analysis. And this is an example of where you don't even have to implement the ML yourself. There's companies like Google that make machine learning models that have already been trained available to other companies as an API. So you can call a Google API right now and pass it the contents of an email, and it'll give back sentiment analysis of that email to indicate, is the writer of that email happy or are they frustrated? And if they are frustrated, how frustrated? Companies can use that information to make sure that that email gets routed either to a service representative or to a manager or to a director, depending on the sentiment that's found within that email. So that can help to create a better bond with the customer and result in a better customer experience.
So going to the next impact area, which is products and services, let's look at some of the areas of value. Self-service is a pretty good one here. So let's take a quick look. An example would be an insurance company that has a lot of new age insurance, life insurance products. That might be the universal life fixed type insurance. And a lot of times when you look at the call center volume of calls coming from brokers, it's all very simplistic questions, meaning they may be looking for a rate of return, or they may be looking at some nuanced rule around that particular product. So what machine learning can do there is you can deploy something like these chatbots, which basically can learn based on the product brochures and product rules, and you can teach the system pretty much to answer those questions. Whereas a broker would have had to dial in and stay on the line, he might be able to just ask a question and the chatbot would provide a subsequent response. And also, based on the response, the broker can actually give it a rating of 1 star to 5 stars. Based on that, the chatbot will further reinforce its learning, saying that, okay, the answer I gave received a 5 star. So that means it's a pretty good answer, and it'll continue to increase the weight it gives to that type of answering when there's a similar question. So that's the product. So if you go to the next one, let's look at risk compliance really quick. And the one of the areas here may be mitigating the different type of risks that exist. So a retailer here is basically looking to go digital to list a lot of products on their e-commerce website. But the problem is they may not have quality data for each of those products. If they happen to list the product with whatever data they have, they may risk a potential issue with a consumer buying a product, with some allergies and ending up in a hospital, a potential liability issue there. So that's a risk there.
So one of the things that machine learning can offer in this situation is to learn the different characteristics of different types of foods and understanding what are the typical ingredients in those types of foods and what are the typical nutrients. And by comparing each product against all the other products again, this is like an outlier anomaly detection problem. If you can detect that, well, all the other milks list calcium as an ingredient, and then you find one that doesn't, then that indicates that there could be a problem with that particular labeling. And similarly with, again, identifying things like nuts or gluten that could have allergy impacts. So being able to mitigate the risk of improperly labeled products being sold on a website is an example where machine learning can add real business value to avoid those risks and those associated costs.
So going to the last one, which is transformational. So let's look at some of these may be creating a very almost a new revenue stream, which did not exist. A lot of this can be found out in types of divergence analysis that we help customers with, knowing what asset of data they have, what kind of customer base they have, being able to look at different other aspects to come up with new products or services that are complementary to what you may have today. So in that sense, there is a financial company we are working with, and they have a lot of byproduct data. So they service credit card transactions between the buyer and seller for a particular type of product, right? And so there is specialization there. So not any product, but very specific set of products. And so we take that data and we categorize that. And categorization is not quite easy because each retailer selling that product names these products in many different ways. So by writing machine learning to kind of combine that and categorize that, we're able to create a database which can be mined for insights. And now there are customers who are looking to understand market behaviors, who are willing to pay to get access to that type of classified classification of data, so they can understand their own market buying patterns and make decisions around that piece. So that net results in a new revenue stream for this particular customer. This would not have been possible without machine learning in the past. At best, a few analysts would have loaded few records into a spreadsheet and then had to extrapolate and may not have the exact number, but with machine learning, you can actually do that today. So going to the last slide here, this is essentially an example of that type of customer where they're bringing this particular data from different places. We're writing a set of machine learning models here that basically classify the data, and writing data services and creating these external system of insight, which is essentially a system that delivers insights to third-party, customers out there who are willing to pay for that access to those insights. So that net results in the overall, new revenue stream for our customer. So we've looked at these 5 different business impact areas. So where do we get started, right? So there are a few challenges, or a few places you could a checklist of sorts, right? To take a look at and see what's the best place to get started.
The first here is data availability. So a lot of companies have been collecting data for several years now, and with the data storage as cheap as it is, a lot of companies collected a lot of data. Looking at that data and understanding, how is it structured, what's its date range, where is it stored, getting an idea and taking that survey is a good first step. The second one is a data and analytics strategy. So understanding what insights could be gleaned, who are the potential users of that information, what are the features that can be mined out of that data, and what other data sets could be added to that same data to make it even more valuable. What synergies could be gleaned by pulling data from a finance department, an HR department, or from a third-party source?
See, the biggest challenge here is actually defining the value proposition of such an initiative in a very clear way. And when you do that, there are probably 13 to 15 ways of defining this. We help our customers with what is the right value proposition and what is easy to achieve. So you can actually get started with a pretty good success story, and then extend your program and keep going with that piece. But having a very defined use case and a budget and a sponsor that is in charge of that budget, interested in solving that business problem, is a pretty good place to start. Of course, there are third-party partners like us, which can bring cross-pollination of ideas for your particular application, industry, and kind of help make that choice. Not only choice around technology, which we do very well, but choice about what aspects of business problem you need to solve, and whether do you have the right kind of data to kind of go build such applications. So that really concludes our presentation. Jeremy, any thoughts in closing?
No, we just want to thank everyone for joining today. Hopefully you found this information valuable and helpful to your business.
Thank you all. Bye.